Ladies and gentlemen, this is not just a truck, and it was never meant to be. What you're about to hear is the story of a vehicle that refused to follow tradition, refused to look familiar, and refused to be built the way the world expected. This machine was designed to survive, to evolve, and to challenge everything we thought we knew about strength, power, and utility. While others perfected the past, this project questioned it. While the industry played it safe, this decision rewrote the rules. Stay with me, because once you understand why this vehicle was created, you'll never look at trucks, technology, or the future of transportation the same way again. And the Cybertruck was developed as a direct response to a changing world where technology, utility, and identity are no longer separate ideas, but a single expectation. It represents a decision to rethink what a pickup truck can be when designed from first principles rather than tradition. Instead of following decades of incremental updates, the goal was to create a vehicle that aligns with a future defined by sustainability, resilience, and advanced manufacturing. The result is a product that challenges assumptions, not for shock value, but to solve problems that conventional designs have accepted for too long. And traditional pickup trucks are built around compromises. They prioritize appearance shaped by legacy aesthetics, often at the cost of efficiency, durability, and adaptability. The Cybertruck rejects that compromise. Its form is dictated by function, manufacturing efficiency, and structural integrity. The exoskeleton design reduces the need for complex internal frames, allowing the body itself to bear load and stress. This approach increases strength while simplifying production, a critical step towards scaling electric vehicles globally without sacrificing performance or safety. And material choice played a central role in this development. Instead of thin stamped panels that dent easily and require paint processes, the Cybertruck uses ultra-hard stainless steel. This material choice improves durability, reduces long-term maintenance, and eliminates paint shops, which are among the most expensive and environmentally impactful parts of vehicle manufacturing. The decision reflects a broader philosophy. If a process does not add value to the customer or the planet, it should be reimagined or removed entirely. And performance expectations also drove the Cybertruck's creation. Electric powertrains offer instant torque, precise control, and fewer moving parts than internal combustion engines. Applying this technology to a pickup platform unlocks capabilities that traditional trucks struggle to deliver consistently. High towing capacity, rapid acceleration under load, and adaptive traction across challenging terrain are not treated as optional features, but as baseline expectations. This ensures the vehicle is not only visually distinctive, but genuinely capable in real-world work environments. And safety was another fundamental reason behind the Cybertruck's development. Pickup trucks are often among the largest vehicles on the road, yet many designs rely on outdated safety assumptions. The Cybertruck's rigid structure, low center of gravity from battery placement, and advanced driver assistance systems are designed to reduce rollover risk and improve occupant protection. At the same time, the vehicle's architecture is intended to better absorb and distribute impact forces, aligning safety outcomes with modern engineering rather than legacy constraints. And the Cybertruck also exists to redefine what utility means in an electric future. Beyond towing and hauling, it integrates energy storage and power output capabilities, allowing it to function as a mobile energy source. This enables new use cases, from powering tools at job sites to providing backup electricity during outages. In this sense, the vehicle is not just transportation, but part of a broader energy ecosystem that supports resilience and independence. And another key reason for its development lies in cultural signaling. Innovation requires visible proof that change is possible. By deliberately breaking away from familiar shapes, the Cybertruck forces conversations about why vehicles look the way they do and whether those choices still make sense. This design acts as a statement that progress does not need to be incremental, and that efficiency, strength, and sustainability can coexist without borrowing validation from the past. And ultimately the Cybertruck was developed to accelerate the transition to sustainable energy by proving that electric vehicles can outperform, outlast, and outthink their conventional counterparts in the most demanding segments. It demonstrates that environmental responsibility does not require sacrificing capability or ambition, and that re-engineering a product from the ground up can unlock solutions that incremental change never could, pushing manufacturing design and consumer expectations into a new phase of technological maturity, and while setting a new benchmark for what industrial design can achieve when it is driven by physics, software, and long-term thinking rather than short-term trends. The Cybertruck reflects an internal belief that vehicles should be built to last not just through ownership cycles, but through decades of use in demanding environments. This belief influenced decisions around corrosion resistance, structural simplicity, and modular systems that can evolve through software updates rather than mechanical replacements. And at its core, the vehicle was designed to integrate seamlessly with a digital ecosystem. Software-defined controls allow continuous improvement long after delivery, enhancing efficiency, capability, and safety through updates rather than recalls. This approach transforms the ownership experience into something dynamic, where the vehicle improves over time instead of degrading. The Cybertruck serves as a platform, not a static product, aligning with the idea that transportation should evolve at the same pace as technology. And manufacturing strategy was equally central to its development. The sharp geometry is not merely a visual statement, but a manufacturing solution. Flat panels and reduced curvature simplify tooling, minimize waste, and shorten production timelines. This efficiency lowers cost barriers over time, making advanced electric vehicles more accessible. Every design decision was evaluated not only for aesthetics or performance, but for how it impacts scalability and global production capacity. And the Cybertruck also addresses a long-standing contradiction in the pickup market. Vehicles marketed as rugged and utilitarian are often fragile in real-world use. Scratches, dents, and corrosion reduce resale value and increase maintenance costs. By prioritizing toughness and minimizing cosmetic vulnerability, the vehicle reframes durability as a core feature rather than an optional upgrade. This shift aligns with a future where products are judged by longevity and function, not disposable appeal. An environmental impact extends beyond tailpipe emissions. The Cybertruck's development considered life cycle efficiency from raw material sourcing to end-of-life recyclability. Electric propulsion reduces operational emissions, while simplified manufacturing processes lower the carbon footprint of production itself. Energy efficiency is treated as a system-wide objective, reinforcing the idea that sustainability is achieved through design discipline, not marketing claims. And the vehicle also reflects a broader understanding of how people use trucks today. Modern work often blends professional and personal needs, requiring flexibility rather than specialization. The Cybertruck accommodates this shift through adaptable storage, configurable bed space, and integrated technology that supports both productivity and everyday use. It is designed to transition effortlessly between worksite, highway, and off-grid environments without compromise. And another driving factor behind its creation was the desire to challenge regulatory and industry inertia. By introducing a radically different approach, the Cybertruck tests existing standards and encourages updates that better reflect modern capabilities. This pressure accelerates progress not only within one company, but across the entire automotive sector, pushing competitors to rethink efficiency, safety, and sustainability. And the Cybertruck also serves as a statement about confidence in engineering. Rather than hiding complexity behind styling, it exposes purpose through form. The design communicates strength, precision, and honesty, reinforcing trust in the underlying technology. This transparency reflects a belief that when a product is engineered correctly, it does not need to disguise itself to gain acceptance. And in practical terms, the vehicle's development acknowledges a future where energy independence becomes increasingly important. With the ability to store and deliver significant electrical power, it supports decentralized energy use and reduces reliance on traditional infrastructure. This capability aligns transportation with broader energy goals, turning vehicles into active participants in a resilient energy network rather than passive consumers. And the Cybertruck ultimately embodies a mindset that progress requires risk, clarity of vision, and willingness to abandon convention. It was developed not to fit neatly into an existing category, but to redefine the category itself. By combining structural innovation, electric performance, software intelligence, and manufacturing efficiency, it represents a deliberate step toward a future where vehicles are stronger, smarter, and more sustainable by design, continuously evolving alongside the systems that support them, and incapable of adapting to changing demands without requiring fundamental redesign. This adaptability was a core reason the Cybertruck was pursued despite the challenges it presented. Instead of optimizing for short-term acceptance, the development focused on long-term relevance, ensuring the vehicle could remain functional and competitive as infrastructure regulations and user expectations evolve. This forward-looking approach treats transportation as an evolving system rather than a finished solution. And a significant motivation behind the Cybertruck was the recognition that electrification alone is not enough to transform mobility. True change requires rethinking how vehicles are engineered, produced, and used. By consolidating multiple functions into fewer components and relying more heavily on software control, complexity is reduced where it does not add value. This simplification improves reliability and creates opportunities for future enhancements that would be impossible in traditional architectures. And the Cybertruck also reflects a belief that strength and efficiency are not opposing forces. Conventional wisdom often assumes that rugged vehicles must be heavy, inefficient, and mechanically complex. Electric powertrains challenge this assumption by delivering high torque with fewer parts and greater control. When combined with a rigid structural design and optimized aerodynamics, the result is a vehicle that delivers capability without unnecessary energy loss. This efficiency translates directly into extended range, reduced operating costs, and improved overall performance. And another factor driving its development was the need to address user trust in new technology. Radical design invites skepticism, but it also provides an opportunity to demonstrate confidence in engineering decisions. The Cybertruck does not rely on superficial familiarity to gain acceptance. Instead, it invites users to experience the benefits firsthand, allowing performance, durability, and functionality to speak for themselves. Over time, this approach builds credibility through use rather than appearance. And connectivity and autonomy readiness were also built into the vehicle from the beginning. Advanced sensor integration and computing capability allow continuous refinement of driver assistance features. This ensures that safety and convenience improve over time, aligning the vehicle with a future where software plays a central role in transportation. The Cybertruck is designed not just to meet current requirements, but to support advancements that have yet to be fully realized. And the decision to develop such a distinct vehicle was also influenced by the need to inspire talent and innovation within the organization. Ambitious projects attract engineers, designers, and builders who are motivated by solving difficult problems rather than repeating established patterns. The Cybertruck served as a catalyst for experimentation in materials science, manufacturing methods, and structural engineering, generating insights that extend beyond a single product. And from an economic perspective, the vehicle challenges assumptions about cost and value. By eliminating unnecessary processes and focusing on durability, it aims to reduce total cost of ownership rather than just initial purchase price. Lower maintenance requirements, reduced energy costs, and long-term resilience contribute to value that accumulates over time. This perspective shifts attention away from short-term incentives toward sustainable economic efficiency. And the Cybertruck also responds to a broader societal shift toward transparency and authenticity. Consumers increasingly value products that reflect clear intent and honest design. By making its structure and purpose evident, the vehicle aligns with this expectation. It communicates that every element exists for a reason, reinforcing trust between product and user. And its development further acknowledges the role of vehicles in emergency response and disaster resilience. The ability to operate off-grid, deliver power, and traverse difficult terrain positions it as a practical asset in situations where conventional infrastructure fails. This capability extends the vehicle's relevance beyond everyday use, integrating it into broader discussions about preparedness and community resilience. And the Cybertruck represents an ongoing experiment in redefining how vehicles fit into a sustainable future. It challenges not only competitors, but also internal assumptions, pushing continuous improvement across design, manufacturing, and software development. Each iteration builds on lessons learned, reinforcing a culture where feedback and data drive progress rather than tradition. And by embracing unconventional solutions and prioritizing long-term impact over immediate approval, the Cybertruck underscores a commitment to innovation that is grounded in engineering reality. It exists as proof that meaningful change requires more than cosmetic updates or incremental improvements. It requires the courage to question fundamentals, the discipline to execute complex ideas, and the patience to allow results to unfold through real-world use and continuous evolution, and reinforcing the idea that a vehicle should never be considered finished at the moment it leaves the factory. Instead, it should be viewed as a living system that learns, adapts, and improves alongside the world it operates in. This philosophy reshapes expectations around ownership, shifting focus from static specifications to long-term capability and relevance. The Cybertruck was developed with this mindset embedded into its architecture, allowing data usage patterns and real-world feedback to inform ongoing refinement. And this approach also acknowledges that the future of transportation is inseparable from the future of energy and infrastructure. Roads, charging networks, and digital systems are evolving rapidly, and vehicles must be prepared to integrate with these changes rather than resist them. The Cybertruck's electrical architecture and computing capacity were designed to support new charging standards, energy sharing models, and intelligent routing systems as they emerge. This readiness reduces the risk of obsolescence and extends the functional lifespan of the vehicle. And another reason behind its development lies in the recognition that design influences behavior. Vehicles shape how people work, travel, and interact with their environment. By offering high utility without dependence on fossil fuels, the Cybertruck encourages a shift in mindset around what powerful tools can look like in a sustainable economy. It demonstrates that responsibility and strength are not mutually exclusive, and that modern engineering can deliver both at scale. And the Cybertruck also challenges long-held assumptions about comfort and technology in utility vehicles. Rather than treating advanced features as luxuries reserved for premium segments, it integrates them as essential components of a modern work platform. User interfaces, automation, and intelligent systems are designed to reduce fatigue, increase awareness, and improve productivity. This elevates the role of technology from novelty to necessity, aligning with the demands of increasingly complex work environments. And its development further reflects an understanding of global diversity in use cases. Trucks are not confined to a single culture or industry. They serve farmers, builders, explorers, emergency responders, and everyday users across vastly different climates and terrains. The Cybertruck was engineered to perform consistently under these varied conditions, reducing reliance on region-specific modifications. This universality supports broader adoption and simplifies global deployment. And the emphasis on durability also responds to concerns about waste and resource efficiency. Products that fail prematurely contribute to environmental strain and economic loss. By prioritizing structural strength, corrosion resistance, and simplified components, the Cybertruck aims to remain operational far longer than conventional alternatives. Longevity becomes a form of sustainability, reducing the need for frequent replacement and conserving resources over time. And from a strategic perspective, the Cybertruck serves as a testbed for ideas that influence future products. Manufacturing techniques, material applications, and software frameworks developed during its creation inform broader innovation across vehicle platforms. This spillover effect amplifies the impact of the project, ensuring that lessons learned extend beyond a single model and contribute to continuous improvement across the organization. And the vehicle also reflects a deliberate effort to restore a sense of excitement around engineering. In an industry often constrained by risk aversion and incrementalism, bold experimentation plays a critical role in progress. The Cybertruck's unconventional nature sparks discussion, curiosity, and critical evaluation, all of which drive advancement. By inviting scrutiny, it accelerates learning and adaptation rather than avoiding discomfort. And its presence on the road acts as a visible signal of transition. Each encounter challenges preconceived notions of what electric vehicles are capable of and who they are for. This visibility helps normalize new technologies, reducing psychological barriers to adoption. Over time, what once appeared radical becomes familiar, paving the way for broader acceptance of sustainable solutions. And the Cybertruck was ultimately developed to align vision with action. It translates abstract goals around sustainability, efficiency, and innovation into a tangible product that operates in the real world. Every design choice reflects an intent to move beyond symbolic gestures and deliver measurable impact through engineering rigor and systemic thinking. And by continuing to evolve through data-driven updates, expanding functionality, and real-world validation, the Cybertruck maintains relevance in a rapidly changing landscape. It stands as an example of how disciplined innovation, when applied without compromise, can redefine expectations and reshape industries, proving that the future of mobility is built not by preserving the familiar, but by reimagining what is possible and committing fully to making it real.